Your microphone is off, teacher.
Hello, everyone. Welcome to the lecture of experimental design. Today it is Monday, the 27th of April 2026, and we are going to start our third subject, which is related with correlation and ANOVA, which is analysis of variance. So, first of all, I will have to tell you about your grades of the previous exam. So I am going to share with you my screen. Okay. Mm, okay. So we are going to solve the exam in order for you to know what the answers were. So let me open the exam here. Okay. 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 So let me share with you my screen. Okay. So this is the exam that you took last week. So what I am going to do now is to solve and to provide you with the answers. So let me put here answers. Okay. And I am going to save it here. Save. Okay. Well, as you could see, our colleague Carlos, which is responsible for the materials laboratory at the Faculty of Architecture and Design, uh, went to our lecture room and he explained to us about this competition of the American Concrete Institute, right? So he was explaining about how this works and the rules, the main rules of the competition, right? So here you can see that there is some brief explanation about the competition, but we are going to read this now. So let me just put this like that. Okay. Mm, 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 mm. Okay. So the first question was about the objectives of the competition. So we are going to read this now. So in the American Concrete Institute, student competition teams must design a concrete beam with fiber reinforced polymer. So this is the first key word, okay? The FRP. So I am going to put it like that. These materials are to maximize structural performance, so this is very important, to maximize structural performance, ultimate load, while considering cost efficiency. You are not designing the beam directly. You are designing the experiment that will lead to the optimal beam. Using the experimental design approach illustrated in our lectures, similar to that of the paper airplane of the first session, propose a full factorial design 2 to the power 3 to optimize the structural performance of the ACI concrete beam. See figure 1. So again, as I explained to you on the classroom, you have the beam, and in the competition, they put two loads in this part of the beam, in the upper part of the beam, and then they start loading the beam. So the beam starts to support these loads, okay? The process ends when the beam is broken, okay? So this is the figure. So the first question was define the objective, which is clearly state the objective of the AC experiment in one sentence. The value of this question was 4 points, okay? So this is the response. To maximize, I am going to copy this. This is the objective, okay? Just like that, you just had to copy this. This was the response. So just put here and put here. Okay, to maximize structural performance, ultimate load, while considering cost efficiency. Okay, that is the first answers to this question. Okay, let us now move on to the second question. Okay, the second question said, uh, selection of factors or variables, 3 factors required. Propose 3 controllable factors relevant to the ACI beam competition. And the value of this answer was 6 points. Okay. So here you could have the first thing was the FRP, reinforcement ratio. FRP reinforcement ratio. The second aspect or factor that you could consider here was the concrete compressive strength. Okay, so do you remember that I told you about this relation between the cement and the water? If you have more cement, the strength of the concrete is greater than the case in which you have more water. If you have more water in the mix, then the resistance is going to decrease, okay? So let me underline this. Here we are. Okay, and the third factor could be the beam depth. You can play with the dimensions of the beam. So it is the beam depth. Here we are. And you can underline this, okay? So these answers provide you with 6 points, 2 points each. Okay. So you should write here the same factors, which is FRP, reinforcement ratio. The second is the concrete strength. And the third point was the beam depth. Okay. So let's put this in bold. This is in bold. And this is as well in bold. Okay, in bold. Perfect. Okay. So here you had to propose some values for the low and the high level of each variable so that you could carry out some exercise later on. So let's suppose here you could propose this radio to be 0.5. 0.5%. And the upper value, it could be 1.5, right? The idea here was for you to propose some values, right? It could be a different value, okay, but the idea was for you to propose some values, okay? So here you can have the justification, which is higher reinforcement higher reinforcement increases the tensile capacity and load resistance. So the more reinforcement you use in the beam, the bigger the load that it will resist, right? So you can play with that. You can put more reinforcement within the beam, and then it will support a bigger load. Okay. So let us look at the second variable. So it is the concrete strength. You can use, for instance, 25 megapascal in the lower level, and in the upper level or the high level, you can use 40 megapascal. Okay. Well, what is the reason to do this? So a stronger concrete improves compressive capacity and stiffness. Okay, so if you use a higher value of the concrete strength, so the capacity is better for the beam. Okay, and finally, in the third variable or factor, which is related to the beam depth, you could use, for instance, 20 centimeters in the low level and you could use, let's say, 30 centimeters in the high level. Okay, that you could play with these dimensions, as you could see here in this figure. You could play with the geometry of the beam. Okay, so what is the reason why this is important? So greater depth increases uh, there is one thing called moment of inertia and load capacity. Okay, you should not know about civil engineering as an expert. The idea here was for you to propose some values, right? You could put here 10 and 15. You could put here any other values. What I wanted was for you to justify your answer. Why you were choosing those values, right? The values are not important for now in this part of the exam. So the important thing was to propose some numbers. That was the idea in this question. Okay, so let us now move to the following question. So here you should design the 8 different combinations. Okay. So you could put either the qualitative values or the quantitative values, okay? So for instance, in the first case, you could have here low, then low, and low. That was going to be the very first combination, okay? Then you could play here, right? You could put in not strictly in this order, but the idea was for you to put the 8 different combination. For instance, you put here high, low, low. Then you put here low, high, low. Okay. And then in the fourth combination, for instance, you could put here high, high, low. Then in the fifth, you could put low, low, high. This is here. Then in the sixth combination, you could put here high, low, high. The seventh, it would be low, high, high. And finally, the eighth, everything is going to be high. So you put high, high, and high. Again, it was correct if you put these values instead of the words. You could put here 0.5, 25, and 20, for instance, in this case, right? In this case. Or you could put here in the very last case, you could put 1.5, 40, and 30. it was correct. Any of them was correct. Okay? Well, let us now move to question number 5. So, response variable. Define the response variable and how it will be measured. Okay. So here you should put the following answer. The response variable here. The response variable is the ultimate load. And you are going to measure that in kilonewtons. Okay? Measured as the maximum load the beam can sustain before failure using a controlled loading test. Okay, that was the answer for this question. So let me put here this underline and put in bolts. Okay, perfect. Well, the following question was related to the order in which you should carry out the experiment to get the results. Okay, so you should put here numbers from 1 to 8, depending on the order of each step. So the first step is select a fixed beam geometry standard to control variables not studied. So that was the first step. The second is to prepare materials, ensuring that consistency across specimens. Okay? Then the third step is related to construct beams according to factor combination. Number 4 is verify dimensions. You should verify the dimensions and materials proportions according to the experimental design. The fifth step is related to cure beams under control, which is this number 5. Under controlled conditions, this means that you should add some water to the mix in order to avoid high temperature. Then the sixth is to randomize. The sixth is to randomize the testing order. You should carry out that step. Then the seventh is to apply the load until failure. That is the seventh step. And finally, the last step is related to recording the ultimate load for each replicate. Okay, so that was the answer for this sixth question. Okay, that is the correct order to carry out this experiment. Okay. And finally, the very last part of the exam says to emphasize the responses provided so far, match the following columns. Place the corresponding letter A, B, C in the given parentheses. Okay. Well, so the first of this is what is the response variable and the answer is D. So this is the response variable, which is D. Is the ultimate load, right? That is the very last thing that we want to know. The second experimental unit, in this case, the experimental unit is letter F, which is the concrete beam. Number three, source of variation. You have a material variability, which is letter J. This is the answer. Number four, a type of experiment, it's factorial experiment, each letter A. Okay. Number five, the number of combinations. You remember, you just put that in the previous question. It is 8, which is related to this answer, H. 8 combinations from low, low, low until high, high, high. Okay. The mean formula, it is letter B. You should add all the values and then divide by the number of values. So this is no letter B. The variance formula, it is letter K, the very last option. It is the sigma square. Okay, that is the formula for the variance. Number 8 is related to hypothesis example. It is letter number, it is C, letter C. H0 is that there is no effect. And then number 9, the tests that you, the test decision rule, it is letter A, which is here. It is reject if P is less than 0.05, okay? Then number 10, graphical analysis tools. It is an histogram, is letter G. And finally, the type of experiment, which is letter E, laboratory experiment. So it is letter E, okay? That's it. If you had these answers, then you could get the total points available for this exam. Okay. So, do you have any questions about the response of the exam?
No, but could you send us this correction?
Yes, it is going to be recorded here, and I am going to put this in the YouTube. So don't worry, you can put stop the video and look for the answers. What I am going to do now is to share with you the your exams. Okay, I have got this. I have scanned every of the exams. So let me just find it here in my computer. Wait a second, please. Okay. Did you receive your grades your on the teams?
Yes, teacher.
Okay. So everybody already knows how was your performance in the exam. So let me just put here. Uh, Okay. So where did I put it? Okay. Mm-mm. Okay. See. Okay. Here we are. Okay. 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 Give me just 1 second. Let me see if I because I left the exams on my office. So, but I took I scanned the exam prior to that. So in the exam. Okay. Okay. Mm, 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 mm. Mm, let me see. Oh, oh. I think that I let this in my computer in the office. I cannot find it here. So let me just double check. Okay. Mm, mm, mm. Yes, I think that I let this in my office in the computer office. Okay. Enter. Let me see. The exam was on the 20th, right? So I graded this 21st. So let me just check. 21st. Okay. Okay. Here. Mm, mm-mm. Oh, it is not here. Okay. View. Let me see if I have this in my USB. So you have your exams or already graded. So let me just see. There is a possibility that the exam is here in this USB. So let me see. Mhm. Here, okay. Ah. Oh, yes, here it is. Okay, okay. I have found it. Okay. So let me. Okay. Okay. Let us do something. I am going to give you your exams. So. And I am going to do it. Um, okay. Copy. Okay. Okay. So this is the first partial exam experimental design graded. It is April 26th, 27th. Okay. Okay. So Okay. 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 Perfect. Well, let me. How can I send you a personal file by Teams or perhaps by WhatsApp? Okay. I am going to stop sharing. Okay. So look, what I am going to do is the following. Here I have the exams. Mm. Wait a second. Here we are. Download. Okay. Okay. So here I have the exams, but the point is that all of them are put together. So what I am going to do is here are all your exams, okay? I am going to put this file on the Teams in the chat. So please download the complete file and then extract your own exam, okay? Because I have put all together. So I am going to add to the chat the exams. Okay. They are alphabetically ordered, okay? So you receive this file, then you open it, and then you look for your own exam, and you can extract it. Okay, you can extract it from there. Okay, I will give you 5 minutes to do that. So I'll see you back at 5 p.m. Okay, so extract your own exam, and you are going to put it on the platform on the Teams, just the extracted file. Okay, so see you in 5 minutes, please. Okay. So, were you able to extract your own exam?
Yes, teacher.
Okay. So, what I am going to ask you to do, please, is to upload that in um, the Teams. Okay. So, for instance, who can help me? I don't know. Alan, can you help me, please?
Yes.
Can you share your screen and let's do the process together. Okay. Okay. So go to the Teams, please. Yes. And then in the homeworks in our team. Exactly. Experimental design. Yes. Aha, homework. So I think that it should say the second option which says vencida here, I think. No, the following option. Okay. Yes, exam one. And look if you can upload this file, please. Attach. Okay. So the idea is to upload just your extracted exam, right? It is already graded, so you already have your evaluation there. But the evidence for this evaluation is the extracted file. Okay. So could you do it? Exactly.
Eh, eh, Todavía no lo había recortado, apenas lo iba a hacer.
Okay. But the point is that you can do it, right? You can upload the exam. If you extract your exam, just 2 pages, then you can put it in the exam one homework, okay? So is it clear? Can everybody do that, please? So we have the exam in the Teams. So has anybody finished to do this? Let me check. Mhm. Okay, perfect. Okay, that's great. Okay, perfect. Excellent. Okay, so apparently most of you have already finished. So here we have the evidence for these grades, okay? Perfect. Okay. So any questions about what you have to do? You just have to extract your exam and then upload this file in the exam one homework, right? From last week. So we are going to have the evidence within the teams, okay? Well, so let us continue now with the today's lecture. I'm going to share again my screen. Okay. Okay, so let us start. Well, experimental design, the lecturer, David Joaquín Delgado Hernández, the program Bachelor in Science in Artificial Intelligence. The duration it is 180 minutes, language English, and to today's date, which is the 27th of April 2026. Okay, so what are the subjects for today's class? Well, first we have 3.1, which is regression and correlation theory. And what is the objective for this part of the course? Well, the objective is to construct and validate linear regression models to characterize the functional relationship between independent and dependent variables. Let me put these variables. Using residual analysis to ensure the adequacy of the predicted patterns for artificial intelligence model integration. That's it. And then the second subject, it is 3.2, which is single factor experiments. What is the objective? Is to design and analyze experiments involving a single independent variable with multiple levels, utilizing analysis of variance, which acronym is ANOVA. ANOVA. To determine if any of the treatments result in a statistically significant difference in the system response. Okay, so this is today the concepts that we are going to study. Okay. Perfect. So let us start with the first thing. Let us talk about a theoretical explanation. Okay, so correlation. A correlation measures the strength and direction of the relationship between two variables. Okay, so this is the symbol to represent correlation is R, and this should be something between -1 and 1. So this is the let me put here. So it should belong to this range, okay? -1 or 1. So what is the interpretation? Well, when you have R equals 1, let's put a low letter. This means that there is a strong positive correlation or relationship, right? Perfect. What about R equals R equals -1? -1. This means that there is a strong negative correlation. And what happens when you have R equals 0? That means that there is no linear relationship. Let us put here relationship here. Okay. So correlation tell us if variables move together but it doesn't say why. So you just have an idea about how these are moving, okay? So let me put some images here. Okay. So I am going to put this figure. Okay. Graphically. Okay. So here is the explanation, right? I'm going to put the source. So let me just copy this. Okay. You can check this information in this website. So look, when you have a positive correlation, what you can see is that as one variable increases, so does the other variable. So one variable in the in this axle, the horizontal axle X, it increases both the vertical axle as well. Okay, the variable in the vertical axle is also increasing. What happens with a negative correlation? When one variable increases, the other variable decreases. Okay, so one variable is increasing here and the other variable is decreasing. And what happens with zero value? Well, there is no correlation. That means that there is no relationship between the two variables, right? They are not related at all. Okay? So this is the graphical explanation of this concept. Okay. Let us now talk about the regression. The regression. Okay, so let us put here in bold. First is the correlation. This is in bold. And then here we have the regression. Okay. So the regression, here let us put it here. We have a model. In this case, we are going to see for the time being just the linear model, okay? The linear model. So here is the aspect that this model will have. So it is something like this, okay? So this is the linear model. Okay. So y is the independent variable. Okay. Then I'm going to put like this, B0, beta 0 is the baseline. It is called the baseline. Then beta 1, it is called the sensitivity. So this means how much y changes with x. Okay. Then epsilon, I'm going to put epsilon is the noise, but before that, let us put x is the dependent variable. X represents the dependent variable. Okay. So this is the shape of the regression model, the linear regression model that we are going to study today. So what is the interpretation? Okay. Regression allows prediction and system understanding. Okay. That is the idea. So let us put something here. I am going to put a graph. Okay. Here we are. So let us put here graphically and then put this example. Okay. And I am going to put here the source of this image. Source. Here we are. So let me copy the address, the URL. Here we go. Okay. Well, so as you can see here, we have the independent variable, and then you have the dependent variable, and these are the data, the information that you have. And this line is the linear regression, right? This is another way to show this expression, right? This is equivalent to this formula just because I took this image from the internet, but the idea is basically the same. So you have some points, and then what you are going to do is to carry out a analysis about these points. Okay, so let us carry out an example in the Excel file to illustrate these concepts. Okay, so let me see. Okay, okay, so let us do the following. Okay, example. Let's put practical example. Okay, I am going to put here a table. So please follow me. So I am going to open an Excel file. Follow me, please. Okay. So let us open an Excel file, and I am going to save it as save as. Let us put here FRP example correlation regression. Okay, I am going to put this name to the file. So let me save it here in my downloads. Okay, save. Perfect. Perfect, perfect. Okay, so in the first cell, imagine what we are going to do is related to the laboratory experiment of the exam, okay, which is the concrete beam. So we are going to have different variables. So first I will put here a specimen. Okay, follow me, please. Then in the second column, I am going to play with the width of the beam. So I am going to put here width. Then in the third column, I am going to play with the height. The column. The next variable, it is going to be the water cement relation. So it is going to be the water cement relation. Okay. And I am going to add a variable which is related with an additive. Okay. And I am going to measure the strength. And here we are going to have the strength noise. So I have 2, 4, 6. I have 7 columns in total. Okay. 7 columns in total. Okay. So I am going to have 16 different specimens. So let us put from 1 until 16. Okay. And the width, I am going to play with 2 different widths, 10 centimeters and 12. So let us put 10, 10, then 12. And I am going to copy this pattern 4 times. 2, 3, 4. Okay. 10, 10, 12, 12, 10, 10, 12, 12, and so on, okay? Then with the height, I am going to play with two different variables, 20, the low level, and 25, the high level. So let us put 20, 20, 20, and 25. So I am going to repeat this, 20 and 25. And I am going to copy this 4 times. Okay. Okay. Then let us play now with the water-cement relation. In this case, we are going to have two different relations. One, the first, the low is 0.45 and the high level will be 0.5. So let us put here 0.45. We repeat this 4 times. And then 0.5. And we repeat this 4 times. Then I copy this and I put it here. So look, what I am doing now is to having all different combinations, right? It is exactly like the thing that we did in the exam. Low, 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 high, low, high, low, low, and so on, okay? It is exactly the same. But here I don't have 8, I have 16. Why? Because I have to add a new variable, which is the additive. The additive helps to carry out, for instance, the dry process of the cement is quickly if you add some additive, okay? Or you can get a better resistance if you add some additive. So that is the idea of the additive, okay? So let us, the first 8 will not have any additive. So you just put 0 8 times. And the second sample of specimens, they are going to have the additive. So let us put number 2. Let us put 2 additives together, okay? Okay. I am going to save this. Perfect. So the strength. When I put this specimen, what I should do is to take it to the laboratory and test it, okay? And I record the value of the strength. So imagine this is hypothetical, okay? This is just for this example. Imagine that I could see here 32. That is the value that I can get from this first experiment with this combination. 10 centimeters width, 20 centimeters height, 0.45 the water cement relation, and there is no additive. So you get a strength of 32. The second specimen is 38, then 35, 41, 28, then 34, 30, 36 twice, 36, 36. Then you have 42, 39, 45, 31 as well, 37, 34, and 40. So you get these results from the laboratory. When you put in the universal machine your specimen, then you start compressing this specimen, and this is the value that you are going to get. Okay. These are the values. Please copy these values in your Excel file. Okay, so look. This is the universal machine. That is the name of this device. Okay. And this is a concrete cylinder. Okay. As you can see, here is some notes. They are put there in order to identify the cylinder. So for instance, the first specimen should say here width 10, height 20, water cement relation 0.45, and no additive. So you put this in order to identify which is the specimen, okay? And then you start pressing this concrete cylinder until it is broken, okay? Here you can see that this is already broken. So it cannot resist anymore because all the load, the stress, already has collapsed this cylinder. Okay, that is what we are doing. So I am going to let this somewhere here. So each of these specimens have some variation, so they are different from each other. Okay. There is some small variation, for instance, between specimen 1 and specimen 2. The only thing that varies here is the height. For instance, both of them have 10 centimeters width, but one has a height of 20, but the other 25. The water cement relation is exactly the same, 0.45 for the two, and there is no additive. And look, the resistance increased, right? Because the height increased from 32 to 38. Okay. So let us now put this formula here. So follow me. You are going to put equals, and you are going to put F2, this value. We are going to add. In my case, this is in Spanish. My Excel is in Spanish. So I should put aleatorio. In English, it will be random. this will give you a random number between 0 and 1. So imagine that this value is 1. You are going to subtract minus 0.5. So that means that if the value of the random number is 1 and you subtract 0.5, this value is going to be precisely 0.5. But what happens if the random number is 0? If you subtract 0.5, the value is going to be minus 0.5. So that is how we are going to have this variation, okay? And let us use a standard deviation of 4. Let's put times 4. Times 4, okay? Okay. So now let us copy this from here to there. Okay. So here we are going to have random numbers, which is the noise. What we are simulating here is the noise, because theoretically you should expect this strength, right? But when you actually go to the universal machine and put the specimen there, there is some variation. Okay, that is the noise. That is the noise. Okay. For instance, in an artificial intelligence model to predict the weather for today, you ask this artificial intelligence model whether today is going to rain or today is going to be a very sunny day. And the noise is this, right? It could say the model, the artificial intelligence model for the weather can say, okay, it is going to rain at 2 p.m. and it is already 2 p.m. in the clock, but it is not raining. It perhaps starts at 2:10, okay, 10 minutes later. These 10 minutes are the noise, okay, because the artificial intelligence model is not perfect. There is always some noise, okay? So it gives you an idea, okay, perfect. But the noise is always present in the model, okay? Well, so let us put here some formula. Let me put this very beautiful. So I am going to use this on the borders. Okay. And let us put here this in bold. This is just aesthetics. And perhaps we can use some gray. Here, some gray. Something like that, okay? So it looks better. Okay. So let us put here, right, some information. So I am going to write here the mean value, mean, which is the average. So the formula is, again, in my case, it is in Spanish. My Excel is in Spanish. You should put promedio, and then you select all these values from G2 until G17. So I close this parenthesis, enter. So this is the mean value of the 16th values, okay? Then I am going to put the standard deviation. And the formula here is, in Spanish, it will be desp est and you select again the same range of values. So these values. You close the parentheses. Okay, that is the standard deviation. Okay, perfect. Now here we are going to use this head variable. We are going to put the 4 variables, which is width, then height, then we are going to put the water cement relation, and then we are going to put the additive. Okay. And here we are going to estimate the correlation. Okay. So let me put this beautiful, all the borders.
Teacher,
Yes.
could you show again the formula for standard deviation, please?
Yes. Here you can see it, right? So in Spanish is desp est, and you open parentheses and put the range of the cells and then close the parentheses.
Thank you.
You are welcome. Okay. So let us put here this in bold and some gray. So it looks very nice, very professional. Here and here. Okay. Okay. So let us estimate the correlation between the 4 variables and the strength noise. Okay. So here is the formula. Look, you should put equals. In Spanish, it is coef de Correl, which is related to the correlation coefficient, okay? Coef de Correl, you choose this formula, and then you have to put first this range from B2 until B17, and then comma, and you choose the G2 from G17. Okay, so I let this formula here. And then you put enter. So this is the correlation coefficient. Okay, let us do exactly the same for the following variables, okay? So in the case of the height, I am going to put equals coef de Correl, correlation coefficient in Spanish, and then I choose the respective values. So I am analyzing the height, so I am going to put here the height. Here we are, then comma, and finally the strength noise, these values, okay, from G2 until G17. And I close the parentheses. Okay. Here we are. Now let us do it with the water cement relation. So it is equals coef the correl, and I choose this branch, okay, which is from here until there, comma, from here until there, and I close the parentheses. Enter. And finally, the additive, I am going to put here equals coef the correl, and I select the range, this range, comma, and this branch. Close the parentheses. And then I put enter. Okay. Let us save this. Okay. Okay. So let us do the following. I am going to put a graph here. I am going to put this down there. Okay. So I select this range and go to the insert graphs. So this is correlation or correlation impact. So this is the width, the height, the water cement relation, and the additive, okay? So visually, you can see that the most relevant impact in the strength noise is the height. It is the one that has the biggest impact on the strength noise, okay? So what is the value? It is 0.63. This is the value, 0.63. And look, the water cement relationship has a negative correlation with the strength noise. That means that the more water you use in the mixed, the less strength you get. And that is certainly some intuitive, okay? It is obvious that if you put so much water in the concrete, well, it is going to be very weak. It is not to be strong. On the contrary, it is going to be a very bad mix of concrete, and the building is going to fall down. It is going to collapse because there is so much water in this mix. Okay. What else? The width is also positively related to the strength, okay? As well as the additive. It is better if you put additive and you get a better strength. You can see here the interpretation. But look, if you use the F9, it modifies automatically. So put your cursor anywhere in the Excel file and you use F9. So look what happens, F9. If you use F9, it moves all the time, random, because it is already programmed in this way, okay? So it is moving, as you can see, it is moving, but the variation is not so great. The variation is not so great. There is always a positive correlation between width, height, and additive, and a negative correlation with water cement relation with the strength noise. Okay. Okay. So if you play with this F9 again, look, it is moving all the time. Can you see it? F9. F9. Okay. Perfect. Any questions? Okay. So let me put here this somewhere here, and I am going to, oh, sorry. I am going to put this somewhere here. Okay. Okay. So let me put this in the Word file. Okay. Muy bien. I am just putting this on the on our file in the doc in the Word document. Okay, so let me just copy this. Okay. Okay. Here we are. And the graphical, the figure, which is also interesting. Okay. Control C, Control B. Okay. Okay. Perfect. Okay, so what I am going to ask you to do is to do the following. So let me, you already have this Excel, right? So let me go back to the Word. Okay, so I have already put this in the Word. This is the practical example. So let me put this down there. Practical example. So these are the images of the laboratory experiment, okay? And here is the table with the results, okay? Laboratory results. So it is exactly the data that we put in the Excel file, but it is put here in the Word in order for you to keep this information fresh. And these are the Excel file calculations for the correlation coefficients. So here is the thing that we estimated in the Excel file, okay? And here is the graphical impact. Okay, so let me put this very small. And use this, okay. Okay, so this is the calculations, okay? So I just copied the Excel file to the Word file. So I am going to put you an exercise. Here we are. So please compute the following correlations with the Excel file. So width versus strength, water, cement versus strength, additive versus strength. Don't use the strength noise. Now use the strength, okay? And the question is, what is the variable or the most influential variable? on strength. Okay, that is the question. So please take some minutes to calculate this, please. Okay. Has anybody finished?
Teacher,
Yes.
this exercise is the same as the previous one, but we don't need to use the strength noise, right?
Exactly. You use the strength, the next column, right? The column. Let us do it together. So let me. So share. This is the Excel. Okay, so let us put here the calculations. Okay, so again, this is going to be something very similar to this. I am going to copy, but put it here. Obviously, this is changing, but instead of using G, I am going to use F. Okay, so this will be B2 and F. B and F. Okay, B and F. So this is going to be B as well, and F here. F. Okay, so enter. Now, in this case, it is going to be C and F. C and F. So it's C and F. Okay, F. Now this is going to be D and F. Okay, D. Oh, sorry. This is going to be D. D. D and F. F. Okay. And finally, additive is going to be E and F. Okay, E and F. So this is going to be E and F. Okay, F. Perfect. Okay. So look, they are somehow similar, right? They are very similar because you see here it is 0.27 and here is 0.30. Here it is 0.70 and here is 0.66, which is very close. Minus 0.5, minus 0.52, and 0.3 and 0.4. Okay, so they are very similar. So the answer is equivalent to the previous exercise. Okay. 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 So let us go to the file options. Add ins. Here. And there is one which is called Analysis Tool Pack. Here, you should add this, please. So again, it is in File, Archivo, Options, Opciones, Add-ins, Complementos, Analysis Tool Pack, which is Herramientas para Análisis, and you put Accept, Activate. Okay, you should have this in order to carry out more exercises, okay? Now you go to datos, data analysis, analizar datos, and you choose regression. Regression. Here we are. And you put accept. Uh, I think that you are not seeing my screen, right?
No, teacher.
Okay, let me share it in a different way. So wait a second. Here we are. Here we are. Okay, so you should go to File, Archivo, Options, Opciones, Add in, which is complementos in Spanish, complementos. Here you put go, ir, down there you put ir, and you select data analysis, herramientas para análisis. You select this, please, and you put accept. Okay. Now you go to the data, data, and you use analysis de datos, data analysis here. At the very top, you use this option, analysis de datos. And then you are going to look for regression, okay? So you can see here different options, but you use regression, okay? And you put accept. Question? Everybody is there? I mean, you can always go back to the video and put a play and pause whenever you are, okay? Okay, so here is the window that we are going to use in order to carry out the regression analysis. So then here you choose in the Y, you choose from F2, let's put here from F2 until F17. In the X range, you are going to choose from B2 until E17 here. Okay. So you choose here in a new sheet, en una hoja nueva, and in a new sheet. And you choose here the normal probability graph at the final box, okay? And you choose the regression curve. You can put this, the rótulos, which is the name. And I think that that's it. And you put accept. Here we are. So it creates a new sheet of Excel, hoja 2, okay, here, with all the results of the regression, okay? So let us now see at the results. And here is the ANOVA as well, the análisis de varianza ANOVA. Okay. Let me put this in order. Okay. Let us put this in this way. Okay. 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 Uh, Here are the results of the exercise. So let us now interpret these results, okay? Uh, there is a very good adjustment, and you can predict very well the strength based on the 4 variables that we already consider, okay? So what you should look here is that this is the correlation coefficient, which is 0.99, which is very close to 1. It is very close to 1. So that means that this is a very good model. It is very correlated, okay? It's a very good model. And here you can have the formula for this thing. So let me copy this. Control C. And I am going to put it here. Here the most influential is the width. The response to this previous exercise is the width. So response is the width. Okay, but let us now move. What about the regression model? So based on the Excel file, we have the following results for the coefficients. Then I am going to put, these are the coefficients. Okay. So that means that the formula for predicting the strength is like this. So let us put here strength equals 38.18, which is the first coefficient, this one here, plus, so this 10 corresponds to the width. Do you remember? This 10 corresponds to the width. So the coefficient is 1.35. So plus 1.35. I am going just to use two decimal values, okay? The width plus 1.19 times the height. Do you remember the height? It is the height here. Plus 95.90 times the water cement relationship. Plus 1.85 the additive. Here is the formula. This is the formula, the regression model that we have calculated. Okay? Okay. Let us prove the regression model. It is a linear regression model, right? Linear regression model. So let us do it. So look, I am going to use this Excel, a new sheet. So let us do it like that. I am going to translate this into Excel again, okay? So, but this will be much better. So I am going to copy these coefficients. Here we are. So the first is the intercept. The second is the width, is the coefficient for the width. Then this is the coefficient for the height. This one is for the water-cement relationship. And finally, the additive. Okay. Okay. So look. If I have values in my first specimen, okay, I have a width of 10. Look, this is the first, okay, this is the first. I am going to put these values, and I'm expecting to have this result. Okay, so let us do it. The width is 10. The height is 20. The water cement ratio is 0.45, and the additive is 0. Okay, so let us estimate this. So here the strength it will be, according to the formula, the regression model is this value plus this coefficient times this width plus this coefficient times this height plus this coefficient. Sorry, aquí is minus. Here is minus, okay? Plus this coefficient times this value plus this coefficient times this value. And look, I am going to do enter. That is very good model. Very good model. This is minus. Sorry, here it is minus. Here is minus. This is the strength. Let me put it here. And let me use this here and this. These are values. Okay. Perfect. 32.36. And the actual value was 32. So let us now try the second specimen. I collected this information in the laboratory, but this is my model. This is my regression model, okay? And I am going to predict, even though I don't go to the laboratory, but I can predict now what is going to happen with my specimen just by having this formula. So let us try. Look, 10, 25, 0.45, 20, 25, 25, 0.45, and 0. So it gives me 38.31, and the value was 38. Okay, now let's try the third. The third is 12, 20, and 0.45. So 12, 12, 20. So it gives me 35, and the actual value is as well 35. So it is a very, very excellent artificial intelligence model. Okay, because it is giving me exactly the result that I am expecting. But there is some noise, obviously. This is the noise 0.6, okay? Because I was expecting 35, but it is giving me 35.06. Let us try with the very last one, the 16th. So it is 12, 25, 0.5, I 2. So 12, 25 here, 25, 0.5, and 2. 39.93, and the expected value was 40. It is an excellent model, okay? Excellent model. So now I can recommend to the student chapter of the American Concrete Institute, which has students from the architectural faculty and the engineering faculty, that in the following competition in Chicago, I think, or in Iowa, I don't remember where is going to take place. I can recommend this. I already have the model for them to try the specimens and then get the first place in the competition, because this is the model that will allow them to win the competition, because it is a very exact prediction. Okay, so let us take as example the number 10. Number 10 is 10, 25, 0.45, 45, and the result is 42.02, and the expected value was 42. So the prediction for the referees of the competition, they are going to be surprised with the precision of this model, because it is very exact model, okay? I took the experiments here to the lab, I recorded the information, and then with Excel, with this Excel, I carried out the regression exercise. So remember to carry out the regression exercise. Let me put here. You go to the datos, analysis the datos, data analysis, and you look for the regression here in all these options, you look for regression. And that's it. You feed all the information that you require, and Excel will calculate automatically for you all the coefficients, the probabilities, and so on. And you are going to have this very good model for the regression, okay? All of them are important because this probability is less than 0.05. 0.05 is the critical value. Okay? Perfect. And here is the analysis of variance. Let me see. Put this here. Okay. This is the analysis of variance. Here we have to carry out another exercise. So let me stop sharing this, and let me share the words again. Word. Here we are. Okay. So this is the model. So the model works very well. Very well. Perfect. That's it. Any questions? So let me put here something about the analysis of variance. So let us put it here, ANOVA. Analysis of variance. So here the goal is to compare means across multiple groups. So here you have 3 or more different groups. So the hypothesis to test is that the means of the populations mu1 equals mu2 equals mu3. So here what we should look is that we should look for variation between groups and variation within groups. Okay. And you have the there is a statistics which is called F from Fisher. So you divide the variation between group and the within group variance, and if you have a large value of F, that means that there is a real effect. If you have a small value of F, that means that the difference are likely to be due to noise. Okay. Perfect. So that is the concept of the ANOVA. So let us ask whether an additive has an impact of the on the groups, right? So look, let me share the Excel file. Excel here. Okay. So look, when you don't have any additive, these are the values, okay? So let's put here data for ANOVA. No additive. So you have here this. These are the values. Okay. And here you have the additive. These are the values. Okay. Save. So in order to carry out the ANOVA, and let us put this one with noise. Let me put this here, and I'm going to put just the values. Just the values. These are changing all the time, so I have to be very careful. No additive with noise. And then I am going to put here just the values. Here. This is additive with noise. Okay, perfect. Okay, so let us carry out the ANOVA. So the ANOVA, you go to the data or datos, analysis de datos, data analysis, and you look for the ANOVA. Here, análisis de varianza de one factor ANOVA. Accept. And this in the range, you can put.
Teacher,
You use, yes?
is ANOVA with a single factor?
Yes,
or
with a single factor.
thing?
A single factor. And you put in a new sheet and you put accept. So it gives you a new sheet, hoja 4. And look, there is no difference. There is no difference because you have a small f. You have a small f, a small value of f. So that means that there is no difference. So apparently the additive doesn't make any difference in the resistance. So the resistances are very similar. Let us look at the data. So here 32, 36, 38, 42. So they are very, very similar. Apparently, the additive is not having any impact on the strength of the specimen, right? How do I know that? Because the ANOVA tells me that this value is greater than 0.05, okay? So that means that it is not significant. It is not significant, okay? Perfect. Okay. Well, and to finish, okay. Okay. So let me just well, is there any questions? We are going to see this in the following class. Remember that the next class is going to be in 2 weeks' time because next Monday we are not going to have a lecture, okay? Because it is going to be a bridge. It is in English. It is called a holiday. We are going to have holiday on the 1st of May because of the work day. Then we are going to have a holiday as well on the 5th of May, which is the Puebla War, and the 4th of May, we are not going to have any lecture. Okay, so let me stop the recording and I will pass the list. Okay, so I am going to stop. Please wait me a second.